Assalamualaikum and greetings to all. I am Siti HANIM LAILA binti Muhammad Mansur from Group B3 for the course SFE3043, Computer Programming and Interfacing, and this is our video regarding the second assignment of Design and Simulation Signal Conditioning Circuit prepared for Dr. Nozaidi Matnawi. Along with me is my other group members, AMIRUL IZZAD bin Ismail and NURSUHADA binti Muhammad TARMIZI, who gave their best to make this task a success. This task is basically a medium to learn on how to apply Wheatstone bridge and an op-amp for strain gauge. The first part of this video would be the design of the Wheatstone bridge circuit on Tinkercad. Without any further, let's get into it.
Assalamualaikum and have a nice day, doctor. We are going to verify our answer in step 1, 2, 3 by building the circuit on this Tinkercad. First of all, the component that we need are a small breadboard, a 9V battery, a multimeter to measure the output of our voltage, and 4 resistors. We state the value of resistor. For R1 is 140 ohm, R2 is 231 and 13 ohm, R3 is our last 3 digit of metric number of the group leader which is 212 ohm, and R4 is the strain gauge at 375 ohm. Let's build the circuit. Firstly, connect all the resistors in the Wheatstone bridge circuit. Then, we make sure all the wire connections are correct, which is the terminal of 9V battery are connected to R1 and R2, and negative terminal of the battery are connecting to the R3 and R4. Please make sure to connect the wire between the R1 to R3 and R2 to R4. Lastly, to measure the output of the voltage, we take a multimeter and connect the negative multimeter between the R2 to R4 and the positive multimeter between the R1 to R3. Finally, we can verify our answer, which is negative 147 mV nearest to negative 0.15 volt. So our VI value will verify. Before get the VI, we are calculating the value of V1 and V2. We are getting the value of V1 is 5.42 volt and V2 is 5.57 volt. To get the value of this voltage of V1 and V2, we must connect the negative multimeter to the ground and positive multimeter to R4. Then we connect the negative multimeter to the ground and positive multimeter to the R3 to get the V1 value. V1 and V2 values are verified nearest to our value of calculating.
For part C of this task, we are required to build a full circuit consists of Wheatstone bridge with a strain gauge connected to differential amplifier. So here we go. The first component we need is a breadboard to form simple electrical connections among the components used. Next, we are going to place an op-amp, which to be specific is an IC741 op-amp in between the terminal strips on the left and right of the breadboard, as you can see in this video. We need to know that the op-amp has 8 pins in total, in which pin 1 is offset null, pin 2 is inverting input, pin 3 is non-inverting input, pin 4 is for the negative power supply, pin 5 is an offset null, pin 6 is for output, pin 7 is for the positive power supply, and pin 8 is not connected to anything. After placing the op-amp on the breadboard, we are now going to place resistors. Pin 2 and pin 3 of the op-amp will then be connected to input resistors indicated by the symbol RA. Pin 6 will then be connected to an output resistor RF, and another resistor RF is placed on the breadboard nowhere connected to any pins of the op-amp. The input resistor RA that is connected to pin 2 will then be jumped through a wire to the output resistor RF. Meanwhile, the other input resistor RA connected to pin 3 is connected to the lower RF resistor through a wire. Next, we are going to connect positive power supply to the breadboard, in which the positive terminal is connected to the positive rail of the breadboard and to pin 7 of the op-amp through wires. Meanwhile, the negative terminal as well as the resistor RF is then connected to the ground through a wire. After that, negative power supply is connected to the breadboard, in which its positive terminal is connected to the positive power rail and pin 4 through wires. Meanwhile, its negative terminal is connected to the ground. Not to forget, a wire is used to connect both negative power rail to ground the lower RF resistor. Now it is time for us to connect this differential amplifier to the Wheatstone bridge. A wire is used to connect the terminal of higher RA resistor to the point V1, and another wire is used to connect the lower RA resistor's terminal to the point V2. A multimeter is then connected to the differential amplifier, in which its positive terminal is connected to the output or pin 6 and its negative terminal is connected to the ground. When we run the simulation, the multimeter connected to the Wheatstone bridge shows a value of output voltage is 145 millivolts. Meanwhile, the multimeter connected to the differential amplifier shows a value of output voltage is 14.5 volts. Now you must be thinking, how does this Wheatstone bridge and differential amplifier work together? Firstly, we need to understand that the Wheatstone bridge is a circuit used for measuring resistance changes in a material, often through the use of a strain gauge. Meanwhile, the differential amplifier is used to amplify the difference in voltage between two input signals. When a strain is applied to the material with the strain gauge, the resistance of the strain gauge changes. This change in resistance unbalances the Wheatstone bridge circuit, causing a voltage difference between the two sides of the bridge, which is V1 and V2. The differential amplifier will then take the voltage difference between V1 and V2 as input and amplifies it to a usable level. This amplified signal can then be used to measure the strain on the material, in which in this task, the output voltage from the Wheatstone bridge is amplified from 145 millivolts to 14.5 volts. And that is all from us. Thank you.